From the Oregon State University's Extension Service, you are listening to In the Woods with the Forestry and Natural Resources Program. This podcast aims to share the voices of researchers, land managers, and members of the public interested in telling the story of how woodlands provide more than just trees. They provide interconnectedness that is essential to your daily life. Stick around to discover a new topic related to forests on each episode.
All right. Welcome back, everyone, to the In the Woods podcast presented by the Forestry and Natural Resources Extension Program at Oregon State University. I'm Scott Leavengood, Extension Specialist in Wood Products, and I'm your host for today's episode on a very hot topic in forestry circles, mass timber. And I'm joined today by a couple colleagues from the TallWood Design Institute.
Morning.
Hey, Scott.
Good morning, gentlemen. Please tell us a little bit more about yourselves and the TallWood Design Institute. And to simplify things a little bit from here on out, I'm simply going to call it TDI. Let's start with you, Iain.
Hi there. My name's Iain Macdonald. I'm the director of the TallWood Design Institute, and I've been in Oregon about 5 years, which roughly corresponds with the time that TDI has been around.
And my name is Evan Schmidt. I'm the Outreach and Education Manager at TallWood Design Institute. I came to Corvallis in 2016. I received my master's in wood science in 2018, and I've been working for TDI ever since.
Great. Give us a little bit of background here on TDI. When was it founded? Who's involved, and so forth?
Yeah, so TDI has been around since about 2016, 2015. We got our name in 2016, but really we're a collaboration between the College of Forestry and the College of Engineering at Oregon State University and the College of Design at University of Oregon. So we're a weird collaboration between the beavers and the ducks. But the idea is to try and work across the disciplines of forestry, wood science, engineering, and architecture to do applied research, to applied education, and really try and create more economic benefit from our forests using kind of a new breed of engineered wood products. Great.
Well, I was thinking that being at a couple of universities, it's focused primarily on the research community, but it sounds like from what you said there, you work also with the users of the mass timber, right?
Yeah, very much so. You know, the state, when they funded us in 2015, I think for the first time, really we're looking at economic development outcomes for Oregon. So, you know, if you think of the jobs that have been lost in the timber industry since the 1980s, when a lot of the federal forests had curtailment of harvests, you know, what we're trying to do is kind of bring those jobs back in new manufacturing enterprises, you know, using the lumber that's already produced and the veneer that's already produced, mass timber, which we'll talk about, I guess, in a few minutes. So we do applied research, we do testing, we work closely with companies who are interested in testing new products, and we work closely with developers and architects who might want to get a design certified for a new building, but they need some independent testing in order to get a permit for that building. So a wide range of different things.
Right. Yeah. And like you said here, and like so often happens when talking with experts and people passionate about their areas of work, we just launched right in, but we probably should take a step back and define our terms. What is mass timber?
Yeah, I can take a stab at that. When people think about mass timber, a lot of times they think CLT, which stands for cross-laminated timber. I'd say it's sort of the poster child of the mass timber movement. And CLT is basically just giant panels of wood made up of layers of dimensional lumber, usually 2x6, and it's glued together in layers of 90 degrees. But really just taking a kind of a more basic approach, mass timbers are massive timbers. They're basically just large structural wood elements used in larger buildings. So instead of using a 2x6 by 8 foot piece of dimension lumber from Home Depot, you're using a glulam beam that's 2 feet deep and 20 feet long and made up of many pieces of dimension lumber. Or instead of using a 4x8 sheet of plywood, you have a 10 foot wide by 40 foot long by 6 inch thick mass plywood panel made up of many sheets of plywood. So these products are significant because they're so much larger in scale than traditional wood products that they can now replace reinforced concrete or structural steel in many applications and in larger buildings. So that's really the significance there. And I guess one way to think about it is, you know, instead of a bunch of 2x6s making up a floor of a building, you can think about it as an entire floor of an apartment might be made up of 1 or 2 pieces of mass timber.
Wow.
I guess what's also important to remember is that mass timber defines both a range of large engineered wood products as well as a type of building construction. And that's typically defined by at least having a significant portion of the building structure made up of mass timber elements.
Great. Yeah. Well, thank you for that, Evan. I've heard these products often referred to as engineered wood products. What's meant by that term?
Right. So wood as a material fluctuates a lot in terms of its properties, whether it's from species to species or from tree to tree, or even what part of the tree the wood was cut from. There can be knots, slope of grain, differences in density, and all sorts of things that affect how strong one piece of wood is compared to another. Simply put, wood is not all created equal. And to complicate matters a little bit further, wood coming out from, let's say, forestry plantations or wood coming out from forests that were harvested to thin for restoration projects can be of a lower quality potentially than what might have been harvested from older trees. So we have to figure out how to build strong materials from a material that might not be perfect. So an engineered wood product takes all this variable wood material, breaks it up into smaller pieces, and then randomly reassembles it into a final product that is far more predictable than a natural piece of wood might be. It's kind of like shuffling a card deck. You randomize things and it creates a more even game. So you can think about how plywood is made from many sheets of veneers that are glued together, or oriented strand board, known as OSB, is a lot of flakes that have been glued together into a panel. And in effect, what's going on is those defects are getting distributed through the material more evenly. So you can significantly shrink the range of variability in performance. So even if you're using worse wood to start with, you can have a higher performance since the overall behavior is more predictable. It's really the important thing. So anyways, back to mass timber, you can think of mass timbers as gigantic engineered wood products, except in this case, the small pieces, and I'm doing air quotes here, small pieces that are glued together are now entire 2x6 boards or entire sheets of plywood. And the end products are giant panels with, again, these sort of predictable qualities.
All right. That's good. Yeah, it's good to know about the predictable qualities of these things that are holding up tall structures. Sounds like what we're talking about here is a real innovation in wood products. So what was the inspiration for CLT and mass plywood? I know they're both made in Oregon. Were they invented here, Iain?
No, actually, these CLT was invented in Austria in about the mid 1990s, and it's interesting. Actually, it's really conceived of nowadays as a very sustainable product, and that's one of the drivers for its use. But originally, the sawmills in Europe were looking for a place to use the side lumber, kind of the lumber that fell off that wasn't much use for anything, and they began to engineer these panels, and this was something that originated in the University of Graz, actually in Austria. So it was a university project. The first manufacturers of mass timber started in Austria, actually, around 1995. It became popular. And then in 2000 and about 2009, British Columbia, Canada started to take an interest in this. They, forest industry, similar to Oregon, very, very important to the provincial economy. And they put some government effort behind trying to promote these materials. And so we saw the first buildings in North America really sort of happened there. And then, things kind of migrated down the I-5 corridor, I guess, to Washington and Oregon really became kind of like the first mover in the United States in terms of these design and manufacturing technologies. So we had the first certified manufacturer of CLT for use in buildings, D.R. Johnson in Douglas County, Riddle, Oregon, got going around 2016. And that was due to some work with the Wood Science and Engineering Department at OSU, actually, who worked with them on their products and helped, test it before they went for their certification. Then a couple of years later, researchers in the same department with Science and Engineering started to work with Freres, a lumber company, who are a plywood manufacturer in the Staten Valley, the Santiam Canyon, I should say. And they invented a whole new category of mass timber panel called a mass ply panel. And that's the one that Evan already talked about, where they've taken the veneer layers and they're building these massive thick panels, can be 3, 4, 5 inches thick. So, we've found that Oregon kind of took the ball and ran with it in terms of mass timber, became the first state to do a bunch of things, to endorse new code provisions for mass timber and all kinds of things. So now we're finding that we've got designers and architects, engineers, and construction firms who are kind of fanning out across the country doing this work, which is really exciting.
That is exciting, yeah. So designers, it sounds like, are excited to work with this new material, huh?
Yeah, exactly. I mean, I think they see a bunch of benefits. Maybe we kind of run through a few of those. Firstly, as Evan said, the sheer size of these panels and beams allows wood to be used in applications that used to be kind of the exclusive domain of concrete or steel. So, we didn't used to be able to build very, very tall or very large with wood. There's good reasons for that. 100 years ago, we didn't have good fire suppression methods. We didn't have the kind of modern zoning and code provisions. And so fire and things like that were obviously concerns. And now we have good data that says that mass timber can perform pretty well in fires, in combination with, sprinkler systems and a whole bunch of other things. But, in terms of benefits, so wood can be used in these bigger buildings, taller buildings. That gets designers and policymakers interested because mass timber is generally more sustainable than concrete or steel. And we often talk about a thing called embodied energy, and that's the amount of energy that's required to produce the materials that are used in the construction process. So you think of what's required for steel, energy goes into forging steel. You look at concrete and the energy required to produce cement. Wood has a much, much lower embodied energy. Essentially the material grows from solar energy, and then there's some processing that happens in sawmills and the like. But that embodied energy means that, it's a more carbon friendly, more, environmentally friendly material than concrete or steel. And then there's other benefits, because these panels can be very, very large, construction can happen very, very quickly. So once you've produced these panels in a factory, you can use what we call a CNC machine, computer numerical control. So that's a machine that uses a three-dimensional CAD drawing to create all the toolpaths and digitally fabricate the panel for a particular place in a building. So you can cut out window openings and door openings and channels for electrical and plumbing and all of that, and even kind of pre-drill, holes for connectors to be applied. So when you get onto the job site, the construction can take place much quicker. First of all, you've got bigger elements, and second, a lot of the prefabrication's been done. So you got lower labor costs on the job site. That's an issue. I mean, that's an advantage because we do have labor shortages in the construction industry, a lot, up and down the West Coast. And then you have other things, the project, the construction phase itself is quicker. So you have lower insurance costs for the developer. You have, less time required to rent scaffolding and cranes and all of the other expensive equipment. And then for the people in the surrounding environment, you have fewer deliveries to site. You don't have all these concrete trucks rolling up. So the job site is less congested, it's cleaner, it's quieter, it's less people on site, so it's inherently safer. And then for designers, wood is an aesthetically pleasing and healthy and inspiring material that they love to work with. And so, having this new palette of materials is really exciting for designers too. And I think, thinking about Oregonians, there's a love of the outdoors and nature, and there's a kind of an affinity with the state's timber industry roots. So all of those things fit really well with mass timber.
Definitely. Yeah. Go ahead, Evan. Sorry.
Oh yeah, sorry. I was just going to add on to that a little bit. There are a number of really interesting environmental considerations and benefits to mass timber, I would say, that are getting the design community particularly interested in mass timber. And it's been really interesting because it's been really creating an engaged architectural community in the realm of forestry. So one area that I think is really intriguing is the connection between, again, restoration forestry and the byproducts that come out of it that are often small diameter trees. They can be of lesser quality or less predictable qualities. Taking these byproducts and being able to put it back into a large engineered wood product creates an economic outlet for these forestry activities. So there's been a lot of excitement generated on that front as well.
Yeah, wow, that's amazing. Long list of advantages there. What about any downsides, gentlemen?
Well, of course, with any material, there are downsides. And I think, probably one of the biggest, it's not specific to the material, but this is a new thing. And so designers, permit officials, insurance firms, construction firms are not as familiar with this. They're getting into it for the first time. And whenever you do that, there's a little bit of trepidation around what's going to happen. And so there can be added costs. Sometimes costs are added along the supply chain because people are hedging against any uncertainty. It's perceived for that reason as being a little bit of a more expensive material. Although we're finding, as developers and designers and construction firms start to get experience with this kind of building, they're able to pencil against concrete or steel, quite often, and in some cases save money over the cost of, building something with concrete or steel. And what I'd say is, to really optimize those costs, the different professionals need to start talking earlier in the construction and design process. So rather than being this kind of passed along the chain kind of approach, which typically happens in a construction project, they need to kind of get together and talk from the beginning. The fabricators of the material, the mass timber manufacturer needs to be sitting in the room with the architect and the developer and the contractor, from kind of day one. Evan, you probably have other things you want to add to that, right?
Yeah, I guess I would just say, kind of iterate what you've been saying, is that the overall downside seems to come down to perceptions of additional work and risk. And I would say it's sort of a chicken and the egg kind of scenario over the last half decade, where you need manufacturers to invest in producing the stuff to bring costs down. But you also need owners and architects and the people that are specifying mass timber to create demand for those manufacturers to make it. But we have been seeing over the years, something like a twofold growth in the industry every year. So it seems to be happening. But yeah, back to risk, it seems like many designers, people in general, are just more comfortable with using conventional materials that we've been using when it comes to larger buildings. So that's concrete, steel. And so it takes a willingness to want to learn and really grow to embrace this new type of construction.
Well, speaking of these conventional materials, steel and concrete, is there some interplay here between these and CLT?
Yeah, steel and concrete are amazing materials. So we're not here to deny that or downplay that. I think what we're here to say is that every material has its right place. And actually, oftentimes buildings are built as hybrids of materials, right? It's pretty rare to see a building made exclusively of one kind of primary material. So an example of how timber interfaces with these materials, it's very common, is cross-laminated timber panels or mass plywood and concrete often go together in floors. So we call these timber concrete composite floor. So you put a concrete topping on top of the wood. And this has all sorts of benefits. It increases the spans, it adds stiffness to the system, it dampens vibration, and adds thermal mass to the system. So there are definite benefits to hybrid systems.
Okay, very interesting. I think people often think that it's pure competition here, but it sounds like they can work and play well together in some cases, right?
Yeah.
So what about species? We have Douglas fir as our state tree of Oregon. It's long been our dominant species used for structural lumber and plywood. Is Douglas fir also leading the way in mass timber?
Yeah, Douglas fir is a great species. It's strong and stiff. It's used by our mass timber manufacturers here in Oregon. That said, around the country and in Canada and other places, we're seeing different species being used that are kind of more regionally specific. So, we have southern yellow pine being used down in the south. We have, SPF, spruce pine fir mix being used in other places. In northern Washington and Canada, I believe there's some use of hemlock. So that's kind of, we think about ponderosa pine here in Oregon as a lesser utilized species we'd like to use more of. It's kind of similar for hemlock in, northern Washington and BC. So, and then in Quebec, one of the oldest North American manufacturers uses black spruce way up in the kind of close to the boreal forest. So it really depends on what's available. And of course, all of these products have to go through kind of a rigorous certification process with testing. But, we're finding that the number of species being used is kind of growing all the time.
Yeah, that certainly sounds like a pretty wide range of species already. Are there other species that are being explored?
I could take that. Yeah, there's interest in other species, for economic and environmental reasons. An interesting example would be, in Europe, they're increasingly looking at hardwoods over softwoods and more specifically beech, since, they're predicting that softwood habitat is going to shrink along with climate change and global warming. Over in our neck of the woods, there's interest in ponderosa pine, like Iain was saying, and white fir, for example, because they represent common species in large swaths of forests that are climate stressed and underburned historically. So forests that need attention and restoration work done to them to keep them healthy. If we could use wood from those forests and these engineered wood products, then there are a few wins. We can mitigate that wildfire risk and sequester carbon at the same time. And then, of course, like I mentioned earlier, we'd be creating an economic outlet to actually pay for that restoration place in the first place. Excuse me.
Yeah, interesting. The shifting gears here a little bit. What about dimensions and lumber grades? Does mass timber require the very best, the top grades of lumber and veneer?
We touched on this a little bit earlier, but yes and no. The standards that define how these products are made specify grade. For example, the standard that defines how you have to make and test CLT, that's the PRG 320, says you have to use a certain grade for the outer layers where the most stress occurs, and then you can use a lower grade for the interior. But these aren't the top grades of lumber. Different CLT species are going to have different design values because of wood variability. Like Iain was saying, back to Doug fir is kind of a premier softwood. But it differs between products. Glulam is another example where you can specify various layups and grades. For instance, in the outer layers, that's where you're getting the most stress. You can basically specify custom layups. So
okay, customizing. So, gentlemen, what sort of research are you doing now at TDI, and what do you see on the horizon?
Well, there's a lot of research going on. I said earlier that we were created to try and promote interdisciplinary collaboration. We have a lot of that going on, but the research really runs the gamut from structural testing, for structural and seismic performance, to work on wood durability. For example, we've got projects looking at what's the impact of moisture and wetting during construction on the strength of connectors used in mass timber. Acoustics is a really important area. We have, if you're using steel and concrete, and this is true of a lot of data in mass timber, just because it's so new, we don't have enough data for designers to be able to evaluate, what kind of floor system should I build up here? What kind of wall system? How do I connect my walls to my floors? So, there's a wealth of information for steel and concrete that have been used in these last buildings for these large buildings for 100 years. But with mass timber, we're kind of starting from, not exactly from scratch, but we just don't have the breadth of data. So a lot of it is just trying to do the testing, provide values for acoustic properties, fire resilience, and all of that. Another area that's really a hot topic is life cycle analysis and carbon impacts. We know that that mass timber is sustainable, but how sustainable is it really? If you're buying a mass timber product, so it's wood and it's got less embodied energy than steel or concrete, but then you're shipping it from Austria to the west coast of the US, is that really more sustainable in the long run? Probably not. So a lot of things are centering on, what is the big picture in terms of the environmental impact of these products? And that kind of crosses over into designers being increasingly interested in forest management methods. Where am I getting my wood from? What's the chain of custody from the forest through the mill to the mass timber mill and to my building? And there's a lot of misconceptions around, does something have to be certified timber to be sustainable? Our feeling is no, but you really have to look hard at every source of wood and where that comes from and how that's being managed. So that's a big topic. I'll just say one of the things that we've done this past year that's quite exciting at TDI is we created this research consortium with 17 companies who are structural engineers, architects, construction firms, manufacturers, and they're pooling their money to do a whole bunch of testing that will kind of help elevate mass timber in terms of how it performs and the data we have that we can take to building permitting officials and so on. So So really a wide range of research going on.
Yeah.
Yeah, and I might tack onto that just to do a plug for the lab that we work in, our lab. So the College of Forestry here at Oregon State University built 2 new buildings within the last few years, including the AA Red Emerson Advanced Wood Products Lab. And that's where TDI is headquartered. And part of that lab has got a very large strong floor and strong wall system. So it's a structural testing lab, and arguably probably the largest in the country dedicated strictly to timber engineering. So right now we have a full 3-story timber structure erected inside of our lab that we're going to be testing soon for seismic purposes.
3 stories. Wow. So years ago, when I first started hearing about these products, the big questions were related to fire and earthquake, and you've touched on fire a couple of times. Are there concerns for earthquake performance as well?
Yeah, so I'm gonna I get this question a lot, and I'm gonna get like kind of weird about it. So if you think about trees, they're basically like cantilever beams sticking out of the earth with massive sails on top made out of foliage, right? And that's actually why wood is so strong in bending, is because trees sway and bend in a storm. Some break and die, and the ones that don't survive to pass on a new generation of stronger trees. So this is natural selection for strong wood.
Yeah.
So nature, in effect, has provided us with this material that's designed to weather strong forces, and seismic performance is one of these arenas that many folks agree wood actually really excels at. It's not only strong, it's also important to emphasize that wood is relatively light as well. So we say it has an excellent strength to weight ratio, again, doing air quotes there. And that's good for earthquakes because less mass in a building is generally ideal. Of course, that depends on how and where it's located. Just kind of as an aside, traditional Japanese architecture mastered certain forms of seismically resilient timber structures just by properly considering how the wood connections work and where that mass is distributed. Anyways, another factor, this is kind of interesting, that makes wood ideal is how well it responds to dynamic loads. So that's loads that come on really quickly and strongly instead of, long persistent loads like just gravity, like weight. So, this comes back to forests. You can think about bursts of wind hitting a grove of trees. It's a lot of load all of a sudden that eventually goes away pretty quickly. Wood takes that shock really well. That's actually one of the reasons CLTs performed well in blast tests that have been done. So that's kind of just another interesting aside. So anyways, in the end, seismic performance really just boils down to the members and the connections. It's really a system-based thing, but wood is just as good as any material for earthquakes.
Very interesting. Yeah, I'm going to take that away as I had never thought of a tree as a cantilevered beam. So great for performance in earthquakes. But what about fire? As you said, what has the research shown there?
Yeah, Iain touched on this a little bit, but fire is a really big topic, as you could likely understand, in the timber building world. And there's actually a really interesting history surrounding mass timber in the U.S. involving the International Code Council. It's the ICC. They basically write the International Building Code, and a committee that they set up years ago to investigate mass timber, particularly considering fire. That was one of the main things they really wanted to look into. And the small and short of it is that there were numerous large-scale so-called compartment fire tests that were set up. So what that is entire furnished apartments. We're talking multiple full-scale apartments were built, and they include furniture, books, you name it, anything that would be a real fuel load in real life, in a real apartment. And then they set them on fire. So some of these apartments had gypsum board in them, some didn't, some had sprinklers, some didn't. And the results overall shocked the committee. It was a committee of fire marshals and engineers and at least one architect that I can think of, because the apartments performed so well. The wood basically seemed to self-extinguish after the primary fire consumed all the fuel in the apartment and even lit the wood surfaces on fire. So anyways, in the end, these tests, along with some other tests that they put on, and they did a global literature review, were the basis for the ICC, that's the International Code Council again, adopting mass timber into the building code. So that's why we can now build up to 18 stories in timber, whereas previously it was limited to something like 6 stories. And I guess just to kind of emphasize why mass timber is different or why that's the case, if we just kind of think back to the fundamentals, fire needs oxygen to combust. Otherwise, it just is smoldering. Large wooden members actually insulate themselves from fire with the char layer that develops as they burn, and they smolder at a very predictable rate. Even with a fire raging nearby, engineers can predict how long it takes for wood to burn through its cross-section as it's smoldering. And engineers have been designing glue lambs for many decades under those principles now. So, thinking about it intuitively, the average person knows you need kindling and small pieces of wood to get a fire going. And even a really big log in a raging fire is going to take hours to burn down. And you really need lots of supplemental fuel to keep it from just simply smoldering. So anyways, back to the research side, I would argue that the research is sort of beyond the basic question of whether mass timber can meet basic fire safety and ratings. And it's moved a little bit more on to improving resins for fire performance, testing new species and assemblies, and in particular, contributing to the realm of performance-based design, where we can get beyond the sort of standards of 1 and 2 and 3 hour fire ratings and actually get into fundamental fire dynamics as a basis for design. But that's a whole other topic. So.
Yeah, right. Well, it certainly sounds like fantastic news for safety and some of the biggest things that people are concerned about. I think Iain touched on this a little bit. What about durability, longevity? How long are these mass timber structures expected to last?
Well, I mentioned old Japanese timber structures. Some of our oldest buildings are timber buildings, and it really boils down to proper design and maintenance, like with any building. Probably even more so, it boils down to culture and how long buildings last on what the culture attributes to their value and the need for the building and the ownership, changing land values. It's often the case that buildings are torn down before their lifespan is even up. So that's one major factor. I guess the important takeaway is any material, including concrete, is susceptible to the environment, particularly moisture and fire. Concrete ages, it cracks, and it's got to be replaced and repaired the same as wood. Steel, for example, is very susceptible to fire and has to be protected oftentimes with intumescent paint, fire retardants that expand. And in some cases, steel is actually protected with wood, which is often the case in mass timber buildings, where the steel connections are concealed behind the mass timber elements. So it's pretty crazy.
Yeah, there's an interesting idea, using wood to protect steel from fire. Okay, well, for one final question for you guys. Let's get back to being in the woods here. How do you think mass timber might impact Oregon forests and our forest landowners?
Well, I think mass timber has been great in uniting stakeholders. We have architects, talking to manufacturers and, woodland owners in ways that they, never made those connections in the past. There's a knock-on supply chain effect to any, this increased demand for mass timber. So as we start to build more with that, there's, of course, increased demand for lumber and plywood, veneers, which go into those products. And so we're starting to replace some of the jobs that were lost, as I mentioned at the beginning, over the last, 30, 40 years in the timber industry. I think that designers are seeing paying much more attention to sourcing, where the wood comes from, how are those forests managed, where that wood is sourced. And so that is great news for woodland owners who are sustainably managing their small forests. We have a project right now that is a very ambitious undertaking. TDI is part of something called the Oregon Mass Timber Coalition. And we're working with various agencies, Business Oregon, the Department of Land Conservation and Development, Oregon Department of Forestry, and the Port of Portland on a big undertaking where we would establish a modular housing factory using mass timber from Oregon and produce small, affordable housing modules at scale, where we can tackle kind of simultaneously, the affordable housing crisis that's affecting a large part of Oregon, as well as reducing wildfire risk by sourcing more of the fiber from forestry restoration work. And then, creating those jobs all along the supply chain from the woodlands through to the sawmills, the mass timber manufacturing facilities, and then the modular housing factory itself and in construction. So I think, we're trying to create these synergistic benefits and, and as well, do good for the environment by reducing the greenhouse gas, the carbon footprint of our built environment. Evan, I'm going to let you have the last word though.
Yeah, sure. I mean, so at risk of repeating a few things that Iain said, I guess I would say what's really amazing about mass timber is that it has captured the hearts and minds of a really wide audience. And I would argue has rejuvenated the question of our forests and forest products in the public eye. People are more open to wood products now. And they're increasingly seen as a potentially major solution to climate change. And through a more nuanced lens than forestry is bad or forestry is good. It's creating connections between industries that have been traditionally siloed. Like Iain said, architects, engineers, builders are all of a sudden interested in forest practices and what different certifications mean. States and counties are interested in the potential use of, again, these restoration byproducts and engineered wood products to mitigate wildfire risks. People are becoming increasingly aware of the fact that people are happier and respond well to wood in the built environment. People like being in wood buildings. So ultimately, there's this connection forming in people's minds between the stewardship of our forests and our natural environments and our built environment, which is really cool. I would argue that the impact goes beyond just increased demand for wood from our forests. A lot of people kind of go straight to that. I would say it really means mass timber is becoming a mechanism for deepening our collective connection to the forest and forest management. There's a really large net of people that believe that proper forest management and building with wood can, again, be this major part of our toolkit in fighting climate change. And they want to play a more active role in that conversation to make sure it's done right. I think that cultural shift will bring additional spotlight to our forests. So it'll become, our forests will become more culturally centered again. There's going to be increasing pride in forestry and wood products. And I think on the flip side, there's going to be increasing pressure to improve our forestry practices over time to reflect these evolving values and the science that's emerging out of our college.
Wow, that's fantastic, gentlemen. And yeah, very true. I think we're certainly seeing how mass timber is bringing together professions that really haven't traditionally worked together. And like you both said earlier, this wood renaissance, which links forestry construction, interior design even, and like you said just now, the linkage to forests and forestry just might warrant its very own podcast episode. We'll see.
Okay, gentlemen, before we wrap up this episode, I have a few more questions for you in what we call the lightning round. So the first question, what is your favorite tree species? We'll start with you, Iain.
Well, I have to stay true to my Scottish roots and say the Douglas fir, named after David Douglas, Scottish botanist, and, so important to Oregon as well.
Yeah, turns out to be on our license plate, I believe, and state tree as well. Yeah, good choice. Evan, that leaves it to you now.
Well, now I feel like a traitor because I was going to say the California live oak or the coast live oak, but I grew up down in California, so I'm a big fan of the oak savanna with those big evergreen oaks. So it's probably where I'd go.
All right. Probably not a lot of relevance there for mass timber for Evan, but certainly for Iain, right? At least not yet. Yeah, live oak CLT would be pretty heavy, wouldn't it? So how about question 2 then? What's a unique tool that you use that helps you with your work? We'll start with you this time, Evan.
Cattle prod? No, I'm just kidding. Most of my work's on the computer, so that's not the most unique tool, but maybe in a more abstract sense, maybe humor is kind of its own tool for keeping work fun and, building relationships.
Yeah. Relationships are important in the industry. Yeah. How about you, Iain? Unique tool.
Yeah, well, I'm kind of like Evan. We have a lot of talented people on our team at TDI who can do technical marvels with equipment, fabrication, testing, but I'm not one of those guys. I'm a pencil pusher and I'm a laptop puncher or whatever. So Probably the most important tool for me would be several cups of tea a day to keep keep the creative juices flowing, I guess.
Fair enough. Okay, lastly, we're moving through these pretty quickly. What other resources can you share related to mass timber for any of our listeners that would like to dive deeper into the subject? Iain.
Yeah, well, we have an interesting resource that we started a few years ago called the Critical Mass Timber Meetup Group, and it's meant to be a way for industry to network with our university community, working on research, and stay abreast of some of the things that we're doing and the impacts for the industry, and just a way to share information and lessons learned. And that community has grown, and since we kind of took it online in the early days of the pandemic, we have close to 1,000 people signed up to that group, and we have monthly events that Evan is curating, and have some great discussions around all kinds of topics related to mass timber. So I'd really encourage people to go to meetup.com and look for Critical Mass Timber Meetup. That's my one.
Interesting. I mean, so we got a theme developing here on the importance of relationships. So, Evan, you get to have the final word here. Other resources.
I definitely agree with Iain. The Critical Mass Timber Meetup's a great starting point. It's free. If you're interested in diving into it a little deeper and maybe kind of moderately formally, we also have been building out a certificate program that has modules that you can take individually. So, for instance, we've got a module that's specifically an introduction to mass timber products, manufacturing, and building systems. So if you kind of want to take like a little bit more of a deep dive, that'd be a good place to start as well. So, yeah. Of course, like the internet is rich with opportunities. So there's lots of articles out there if you're just trying to kind of learn a little bit informally.
Yeah, tons of stuff, especially as hot a topic as mass timber is nowadays. I was thinking your TallWood Design Institute website as well. If I remember right, you have this virtual institute tour there. Is that right?
Yeah, we have a scan, a 3D scan of our lab. So it's actually pretty cool. You can kind of like navigate like a ghost through the lab and look at the different equipment and learn a little bit about it. So we'll make sure to share those links with you guys.
Sounds good. I know people are always asking to have tours of the facilities here, especially the one you guys are in, the newest and highest tech. So yeah, I'll make sure people get a chance to take that tour, whether they're in Corvallis or not. So that's it. Iain, Evan, really great to have you both today. Mass timber is, again, certainly a really hot topic. I'm glad we had this opportunity to pick your brains a bit, and I will allow you each to say a farewell.
All right. Well, yeah, thanks, guys. Great being here.
All right.
Thanks for having us, Scott. It was great.
Pleasure. Well, this concludes another episode of OSU Forestry and Natural Resource Extension's In the Woods podcast series. Thank you all so much for listening. Don't forget to subscribe. Bye-bye, all.
Thank you so much for listening. Show notes with links mentioned on each episode are available on our website, inthewoodspodcast.com. We would love to hear from you. Visit the Tell Us What You Think tab on our website to leave us a comment, suggest a guest or topic, or ask a question that can be featured in a future episode. And also, give us your feedback by filling out our survey. In the Woods was created by Lauren Grand, Jacob Putney, Carrie Berger, Jason O'Brien, and Stephen Fitzgerald, who are all members of the Oregon State University Forestry and Natural Resources Extension Team. Episodes are edited and produced by Kellen Soriano. Music for In the Woods was composed by Jeffrey Hino, and graphic design was created by Christina Freehoff. We hope you enjoyed the episode, and we can't wait to talk to you again next month. Until then, what's in your woods?